Good afternoon, children. Good afternoon, students. I try to cover some points relevant to the nuclear physics because due to online classes that work assigned to the another faculty, I'll try to discuss some points relevant to the nuclear physics that will help you to attempt exam on Wednesday. Okay, I'll take that point now. Everyone note down that. The topic is pair production and pair annihilation. Pair production and pair annihilation. Pair annihilation is not visible. I have to write the point once again. Pair production and pair annihilation. Pair production, pair annihilation. What is the meaning of those two? Pair production and pair annihilation. First define pair production. Pair production. Later I move to the pair annihilation. Now first one I had to define the pair production. An energetic gamma rays. Photons fall on a heavy substance and it is absorbed by some nucleus of substance. Some nucleus of substance and its energy gives rise to production of, and its energy gives the production of protons. First one is positrons and electrons. Such process is called pair production. See now, pair production. In energetic gamma rays, photons fall on heavy substance some are absorbed by the nucleus and it releases some energy. That energy contains positrons and electrons. Such a production is called pair production. Such a production is called pair production. Such production is called pair production. Okay? That is the definition of the pair production. Later, the whole definition you are represented in diagrammatically. It gives the clear concept for the term, that is pair production. Here what happening now? Gamma rays or the gamma ray, what I told earlier, nothing but photons whose energy according to Einstein principle is h nu. They are now hit the one of the heavy substance that is named as nucleus. That is named as nucleus. Then what way it should be split? It is now split into, one is positron, another one is electron. They are represented by 1 beta O, other one minus 1 beta O. It is called electron. This sign indicates the positron. It is called electron, other one is called the positron. It is called the electron, another one is called positron. From this, what you have to define? H nu tends to, one is minus 1 beta O plus 1 beta O. That way, the energy is coming out from the heavy substance in the form of pairs. The one is called the electron, other one is called the proton. Now you want to find an energy. Already know the formula E equals to mc square. You have to find the least energy of photon, least energy of photon. You want to define least energy of photon. That one how to describe now? E equals to, what is the value of m? 9.1 into 10 power minus 31. That is the mass of the electron. And C is nothing but 3 into 10 power 8 whole square. 3 into 10 power 8 whole square. Then the value you are getting at this place is 1.64 into 10 power minus 13 joules. You want to convert this in terms of MeV. Divide the whole value by 1.64 into 10 power minus 13 divided by 1.6 into 10 power minus 13. 1.6 into 10 power minus 13. Then the value will obtain in the form of MeV. That is 1.02 MeV. The energy is coming out in case of pair production. How much it is? In case of pair production, how much it is? 1.02 MeV. 1.02 MeV. Note down that one. 1.02 MeV. 1.02 MeV. That is the concept of pair production. Next one, I will move to the second term. What is that? Pair annihilation. Pair annihilation. Pair annihilation. Next term is next one I define pair pair annihilation. Pair production. Second one is pair annihilation. Here the first thing is definition. The converse phenomena of pair production is called pair annihilation. The converse phenomena of the pair production is called pair annihilation. What is coming out in earlier case? Heavy nucleus photon hit the heavy nucleus. H nu is the energy of the photon hit the heavy nucleus. Then it will splits into positrons and electrons. Now reverse the process now. Electrons and positrons. Now here the point. Electrons and positrons come very close to each other, and they produce each other, and then they produce 2 gamma photons. This is an actual function performed by pair annihilation. Electrons and positrons, they combine each other, then they produce the 2 gamma photons. What I had represented 1 beta O plus 1 beta O, that tends to 2 times of this. Means how to represent H nu plus H nu. Minus 1 beta means what? Electron. This is nothing but positron. Then it comes now how many? 2 times gamma photons. 2 times gamma photons. That is a concept relevant to the pair annihilation. Electrons and positrons are combined, then it releases the 2 gamma photons. Is called pair annihilation. Next, variation of binding energy per nucleon with mass number. By variation of binding energy per nucleon with mass number. How to discuss this? For this purpose, you take the diagram support or the graph support. X-axis is A, nothing but the mass number, and the y-axis is the binding energy per nucleon. That is the way to represent. You consider the scale now. The values which one defines all are in terms of MeV. Now the graph come like this. Initially very sharply increases, later falls, again goes on increases, and later decreases, and it should be exponentially decreases later. The graph describes that variation of mass number with respect to the binding energy per nucleon. Now the different elements are coming now. One He, one H1, next one lithium, next one is nitrogen, another one is iron, because the different elements they are. Iron, and it is the uranium. Now here the carbon, and here the representation of the helium. These are the different elements and whose their binding energy per nucleon varied with respect to the mass number. From this graph, important conclusions are there that will help us now list out those. Once increasing this value, it is also goes on increasing very sharply. Later it will decreases. That point I am writing now. A increases, binding energy per nucleon also increases sharply. Also increases sharply and reaches maximum. After that it decreases. Later decreases. That is the point. Second one now. Now the average binding energy maximum value, this one now. The average binding energy is maximum. Binding energy is maximum for iron. That is the value of iron is 8.07 MeV divided by A. Means binding energy per nucleon will come 8.07. Some books are 8.75 also given. You are confusing that one. You are sticky about that. I'll clear the point now. Clear the point. 8.75 MeV per. Okay. Next, for deuterium, the value is 1 MeV. For deuterium, the value is 1 MeV. Next, average binding energy. Next point, average binding energy. Low for light and heavy nuclei. Average binding energy is low for light and heavy nuclei. Here the range also there. That will I tell you now. For lighter nuclei, now next one now. For lighter nuclei, next point. For lighter nuclei, A value is less than 30. For heavier nuclei, A value is greater than 170. A value is greater than 170. Next, 170. These are the points you are observed from this graph. Okay. Next point, from this another one now. Greater stability for greater stability heavy nucleus for greater stability heavy nucleus breaks into heavy nucleus breaks into lighter nuclei. Is called nuclear fission. That is the definition of nuclear fission. nuclear fission. Now the heavy nucleus breaks into lighter nuclei is called the nuclear fission. Nuclear fission. You reverse the process now. Then to attain, another one I am defining now. To attain greater stability, to attain greater stability, to attain greater stability, to lighter nuclei, to lighter nuclei combine, to lighter nuclei combine to form, lighter nuclei combine to form a stable heavy nucleus. Form a stable heavy nucleus. What this process is called? This process is called nuclear fusion. Fusion. Nuclear fusion. These two processes are a reversed process. Nuclear fusion. After this, it is called the nuclear fusion. Nuclear fusion. Okay. Nuclear fusion. Now here observe that greater stability, two lighter nuclei to form a stable heavy nucleus is called nuclear fission. From the greater stability heavy nucleus breaks into two. Two smaller nuclei combine to form the heavy is called nuclear fusion. Heavy splits into two lighter nuclei is nothing but nuclear fission. Nuclear fission. Note down those points. Nuclear fission. Earlier one is the nuclear fusion. Nuclear fission and another one is nuclear fusion. Next one now. I'll go to some more points relevant to the point here. Discovery of neutron. Discovery of neutron. Discovery of neutron. Note on that. Discovery of neutron. Now Chadwick discovered